Our Earth is a dynamic celestial body, constantly in motion. Its most familiar movement is its daily rotation on its axis, a graceful spin that dictates the rhythm of our lives, bringing us the comforting cycle of day and night. This rotation is so fundamental, so utterly dependable, that we seldom pause to consider its profound importance. Imagine for a moment if this constant, reassuring waltz through space were to abruptly cease. This is not merely a minor alteration to our planetary routine. It would represent a colossal shift in the very fabric of Earth's existence. We often take this planetary pirouette for granted, yet it is the silent engine powering countless terrestrial systems, from the gentle ebb and flow of tides to the grand sweeping currents of our oceans and atmosphere. Without this ceaseless spin, the Earth as we recognize it would vanish, transforming into a realm alien and unimaginably hostile. What then would an abrupt halt truly signify for us, for the very air we breathe, and for the solid ground beneath our feet? The question naturally arises, why does our Earth spin at all? The answer lies deep in the cosmic past, a legacy from the birth of our solar system itself. Billions of years ago, before the sun ignited and before planets took shape, there existed a vast, swirling nebula, an immense cloud of interstellar gas and dust. As this primordial cloud began to collapse under its own gravity, drawn inwards to form our sun and its planetary companions, it also began to rotate faster and faster. This phenomenon is a direct consequence of a fundamental law of physics known as the conservation of angular momentum. Think of an ice skater performing a spin. As they draw their arms inwards, their rotational speed increases dramatically. Earth, therefore, was born spinning, a majestic inheritance from that ancient contracting cloud, and it has continued this cosmic ballet ever since, a steady twirl defining its journey through the universe. Now let us engage in a thought experiment. Picture our planet, rotating at speeds exceeding 1,600 kilometers per hour at the equator, suddenly, inexplicably, coming to a dead stop. The sheer concept is staggering. While such an event is not something that could realistically occur without an inconceivable external force or a complete defiance of known physics, contemplating this scenario is more than just an exercise in idle curiosity. It allows us to gain a deeper appreciation for the intricate and often delicate balance of forces that govern our world. The abrupt cessation of Earth's spin would unravel the familiar tapestry of our environment, revealing the profound interconnectedness of planetary mechanics and the very possibility of life. It is an invitation to explore a hypothetical world where the established rules are shattered, and the consequences cascade through every facet of existence, painting a picture both terrifying and illuminating. The immediate effects of such a sudden halt would be nothing short of cataclysmic, far surpassing any disaster scenario ever conceived by the human imagination. This would not be a gentle deceleration, a slow winding down. Instead, it would be an instantaneous, jarring cessation of motion for the solid body of the planet. However, everything not intrinsically fused to the Earth's crust, the atmosphere, the oceans, buildings, trees, and indeed all living creatures, would continue to move due to inertia, maintaining their eastward momentum. This differential motion would unleash forces of unimaginable fury across the entire globe. This isn't merely about experiencing an exceptionally long day. It is about the fundamental laws of physics asserting themselves on a planetary scale with devastating, world-altering power. We are about to delve into a scenario where our planet is thrown into utter, unimaginable chaos by the simple act of stopping its daily spin. The very instant Earth's solid body ceases its rotation, the law of inertia would take dramatic and devastating center stage. Everything residing on the planet's surface, from the smallest pebble to the largest skyscraper, including every human being, every animal, and every tree, would continue its eastward journey at Earth's original rotational speed. Near the equator, this velocity is approximately 1,670 kilometers per hour, a speed significantly faster than that of sound in air at sea level. To visualize this, imagine being a passenger in a superfast vehicle that slams into an immovable wall. Now scale that concept up to a planetary level, where the vehicle is the ground beneath your feet and everything loose upon it is flung violently eastward. This would not be a gentle push. It would be a supersonic, abrasive scouring of the Earth's entire surface, an event of unimaginable violence. The scale of the ensuing destruction is almost impossible to fully comprehend. Buildings, no matter how sturdily constructed, would be ripped from their foundations, torn apart, and pulverized into fine dust within moments. Entire cities would be obliterated, reduced to rubble, and then scattered across the landscape like sand. Even vast mountain ranges could potentially crumble and shear under the colossal stresses generated. The kinetic energy involved in this sudden decoupling of the surface from the planet's spin is truly immense. Anything not an integral part of the Earth's solid crust would effectively transform into a high-velocity projectile, contributing to a global cataclysm that would erase established landscapes and redefine the planet's surface in a terrifyingly short span of time. The silence that would eventually follow such an event would be the profound silence of utter global devastation. It isn't merely solid objects that would be subject to these enormous forces. The Earth's atmosphere, a vast ocean of air, would also continue its eastward dash across the now stationary surface. This would generate winds of unimaginable ferocity, global hyper-hurricanes with speeds far exceeding any storm ever recorded in human history, potentially approaching the original speed of rotation. These winds would scour the planet relentlessly, stripping away topsoil, eroding solid rock, and carrying unimaginable quantities of debris for thousands of kilometers. The immense friction generated by these super-fast winds moving over the surface would also create incredible heat, possibly igniting widespread global firestorms, adding another layer of devastation to an already nightmarish scenario. The sky itself would become a deadly adversary, a raging, superheated tempest making surface survival utterly impossible. And what of the Earth's vast oceans, seas, and lakes? The enormous bodies of water possessing immense collective momentum would surge uncontrollably across the continents, manifesting as colossal tsunamis, potentially kilometers high. These unimaginable waves would travel at speeds comparable to a jet aircraft, sweeping far inland from all coastlines, submerging vast swaths of land that have never before known the touch of the sea. Coastal regions, home to a significant portion of the world's population and ecosystems, would be instantaneously and completely obliterated. Even areas situated far inland, hundreds or even thousands of kilometers from any current shoreline, would likely be inundated by these world-girdling surges of water, which would then violently recede, dragging unimaginable amounts of material back into the newly chaotic seas, fundamentally reshaping continents in a matter of mere hours. Supposing, for the sake of continuing our thought experiment, that Earth somehow weathered the initial, instantaneous cataclysm, perhaps by imagining a gradual, albeit geologically swift, cessation of spin, the long-term changes would be equally profound. The most immediate and obvious alteration to our daily lives, or what remained of them, would be the nature of the day-night cycle. Without its axial rotation, one complete day on Earth would last an entire year. This translates to approximately 6 months of continuous, unyielding sunlight for any given point on the planet, followed by an equally long 6 months of perpetual frigid darkness. This starkly different rhythm is a far cry from the familiar 24-hour cycle that has governed the evolution and behavior of life for billions of years, presenting an almost insurmountable challenge for any surviving organisms and their biological clocks. The temperature differentials between the sun-drenched side and the shadow-cloaked side of this non-rotating Earth would become incredibly extreme. The hemisphere perpetually facing the sun would bake under its relentless gaze, with surface temperatures soaring to levels capable of boiling water across vast regions, and perhaps even melting softer metals like lead closer to the subsolar point. Conversely, the hemisphere plunged into the 6-month-long night would radiate its stored heat out into the cold vacuum of space, causing temperatures to plummet to unimaginable lows, far colder than the most frigid winters ever recorded in Antarctica. Only a relatively narrow terminator zone, the twilight band slowly migrating around the planet as Earth orbits the sun, might offer temperatures that are, in a very relative sense, vaguely tolerable, though still subject to extreme gradients and powerful slow-moving weather systems driven by this thermal imbalance. Furthermore, Earth's current shape is not a perfect sphere. It is an oblate spheroid bulging slightly at the equator and flattened at the poles due to the centrifugal forces generated by its spin. If this rotation were to cease, the relentless pull of gravity would gradually reshape our planet into a perfect sphere. This seemingly subtle alteration in global geometry would have dramatic consequences for the distribution of Earth's waters. The oceans, no longer partly sustained at the equator by rotational forces, would migrate towards the poles. This would lead to the emergence of two enormous polar oceans, submerging vast areas of what is currently Arctic and Antarctic land, while simultaneously causing a retreat of water from equatorial regions, exposing a massive continuous landmass, a kind of supercontinent, girdling the planet's new waistline. Another critical long-term consequence concerns our planet's protective magnetic field. This invisible shield, vital for deflecting harmful solar winds and cosmic radiation, is largely generated by the geodynamo effect, the complex convective movements of molten iron within Earth's spinning outer core. If Earth were to stop rotating or its rotation significantly slowed, this internal dynamo would likely falter and eventually cease to function effectively. Without the protection of its magnetosphere, Earth would be directly exposed to the full intensity of charged particles from the Sun and deep space. This bombardment would significantly increase surface radiation levels, proving lethal for most forms of life. And over geological timescales, it would contribute to the gradual stripping away of our atmosphere into space, leaving our world increasingly barren and vulnerable. It is crucial to reiterate that the immediate catastrophic effects of a sudden halt to Earth's rotation, as detailed earlier, would almost certainly signify the end of human civilization as we know it, and indeed, the extinction of most, if not all, complex surface life. The sheer unadulterated violence of being flung eastward at supersonic speeds, combined with the subsequent onslaught of hyperhurricanes and continent-drowning tsunamis, would leave very few, if any, survivors on the planet's surface. Therefore, any discussion regarding long-term human survival in such a scenario must operate under the assumption of either a miraculously gradual stop, a process taking many years or decades, or the existence of a tiny, incredibly well-prepared, and deeply sheltered subterranean population, somehow shielded from the initial planetary scouring. The scale of the primary disaster is so immense that it strains credulity to imagine a pathway beyond it for those caught unprotected. For any hypothetical human survivors who might emerge from deep, reinforced bunkers after the initial chaos subsided, the new Earth would present an alien and profoundly hostile environment. Imagine stepping out onto a world where you face 6 months of continuous scorching daylight, intense enough to make the surface uninhabitable, followed by an equally long period of absolute bone-chilling darkness and extreme cold. The challenge of simply acquiring basic resources like food and water would become monumental. Traditional agriculture would be impossible across most of the planet due to these extreme temperature swings and the altered light cycles. Access to liquid water would also become a critical and constant concern, with vast quantities either frozen solid on the dark side or potentially vaporized on the sunlit side, leaving only specific, precarious regions viable. The Terminator Zone, that slowly creeping band of perpetual twilight that would inch its way around the Earth over the course of a year, might initially seem like the most plausible or perhaps only location for any form of long-term human habitation. Within this narrow strip, temperatures could theoretically be less extreme than in the regions of perpetual day or night, potentially allowing for the existence of liquid water. However, life in such a zone would necessitate a fundamentally nomadic existence. Human communities would be forced into a constant slow migration, perpetually chasing this habitable band of dim light, always fleeing either the advancing inferno of the sunlit side or the creeping life-extinguishing frost of the dark side. Society, if it could even be called that, would need to be entirely restructured around this relentless planetary pursuit of a fleetingly habitable sliver of land. This rather dramatic thought experiment, while exploring an exceedingly improbable scenario, serves to powerfully underscore a profound and often overlooked truth. Life as we know it on Earth exists within a remarkably delicate and intricate balance of cosmic conditions. Our planet's rotation, a feature so constant that it fades into the background of our awareness, is in reality just as crucial to our existence as its optimal distance from the Sun, the composition of its atmosphere, or the presence of liquid water. Contemplating its absence forces us to confront and appreciate the complex interplay of physical laws and planetary characteristics that make our world a habitable haven in the vastness of space. Perhaps then, the ultimate question arising from this exploration is not merely what terrifying consequences would ensue if Earth stopped spinning, but rather, how can we foster a deeper sense of wonder, responsibility, and stewardship for the spinning, vibrant marvel that is, and hopefully always will be, our home.